Hi everyone, welcome. In this session, we are going to talk about automatic microservice observability with Ballerina. So first of all, I'll give a small introduction on to what Ballerina is. So Ballerina is a programming language geared towards cloud native development. And in this session, I'm going to concentrate primarily on the observability support we have in the language itself and how automatic microservices observability can be achieved using the language features. So if we take a look at the agenda today, um, I'll be like first starting off with a simple hello world program to show how everything looks and feel. And then I'm going to give a small introduction to Ballerina services. And then the main content will be based on this specific integration scenario I'm going to work on. There I'm going to get a specific services integration scenario and show how observability, mainly automated observability, is applied there and how it works with metrics, distributed tracing, and also how different communication protocols interact and allow these observability features to be implemented and used. And in the end, I'm also going to show how these features can be integrated with a cloud solution also on processing and visualizing the observability information. Um, so I'll be basically going through some services and these different solutions that you can use to bring all of these together. Um, so let's start off with the Hello World program. Uh, so for this, I'll quickly jump over to VS Code. So we have a VS Code Ballerina plugin, which you can go to the marketplace and install. Also, for the latest version, the current development version, you can also go to the ballerina.io website and download the V6 file as well. So here I have already installed uh, the the plugin, and so let me create a new project. So I'm going to say bal new hello. So here a new Ballerina package is created, and with a with some sample source code as well. So here I'm not just going to do a normal hello world, but rather I'm going to create a service which does a hello world. So let's see how we can do that. So here we say service HTTP like a code snippet template, and we can fill in the information there. So in Ballerina, we have a service construct that you can directly use. And so here we have created an HTTP service, and inside that we can define resources. So I'm just going to say greeting. We don't need this, and it'll return a string. So that's it for the service. Let's try to basically run this. So when you say bal run, it'll build the existing package and compile it and run it using the same command. So our program is up. Then let's just do a curl against our service. So it's at port 8080, and our context is greeting. So we see we got the hello world back. So that's the basic a basic hello world program. Um, Also, I'll quickly explain more on how a Ballerina service is made up. base, so as I mentioned, in Ballerina, we have a service construct. That's a first class concept in the language. So the service construct, the type of service is dependent on the listener you attach it to, or you basically bind it to. So here, for example, if my service binds to an HTTP listener, it becomes an HTTP service. Then its service, the resource, the formats, and its other behavior depends on the HTTP services uh, way of doing things. So here, when it's bound to an HTTP listener in an HTTP service, we can have these resource functions, and also in different types of services. For example, in gRPC, we have other remote functions as well. So to have like RPC style uh, functions. So here it's a resource. Basically, it basically maps to HTTP resources. So the difference between remote and resource function is like it's like a noun and verb relationship. So in a resource, you say, give a noun saying, okay, I, I'm going to access this. In a remote function, you are doing something, a verb, like in gRPC, let's say add numbers or something like that. So depending on those types, so we have these two different types of functions, and that's controlled by the type of services you have as well. So here, so the service has a service name. So in the HTTP scenario, it maps to the base path. And also we have in the resource function, we have a resource accessor and the resource name. Resource accessor, again, like the approach you, the method you access the resource. So this is directly mapped to the HTTP method that you use, access the resource. So here it can have get, post, and so on, any type you want. Um, and the resource name. So resource name also by default, it maps to the resource context. So it can be updated to have other resource level parameters, and also with the resource function parameters, you can define query parameters and so on as well. And also there are features to do data binding as well, by getting a structure type and binding it to the input body and so on. So all of those can be defined in a Ballerina service. So that's the basic basic overview of Ballerina service. Let's get back to our earlier Hello World program. So after we have a service, now back to our main topic on observability. Okay, how do we observe this? So uh, one thing you can do in Ballerina is basically you can say to this Ballerina package to enable observability globally. So you can create a file called config.toml, and say observability is enabled. So say that, and you also have to put these imports at this moment. So with this, now if I run our service again, you can see we got like more logs printed here. Specifically, it starts up an endpoint for Prometheus servers to connect here. Like it exposes the metrics from this endpoint. So a Prometheus server can pull data out of here. And also it's publishing traces to a Jaeger server by default. So it's using OpenTelemetry protocol. And so using these two, we can get uh, all the information that's there in our service. So by default, it tracks all the resource invocations and all other client invocations that are done, like maybe an HTTP client, another different kind of connector, and so on. These are all tracked in the Ballerina runtime. So let me uh, demonstrate how this basically works. So for this, I'm going to start up a Prometheus server and also a Jaeger and Grafana as well for the visualization. So here I'm going to just use Docker to start up these servers. So first Prometheus server, Grafana, and the Jaeger. Okay, now we have these up and running. So let me just send some pull requests. Go to Grafana and configure the data sources and the dashboards. So let's first add the Prometheus data source. Okay. Then we'll add the dashboard as well. So there's a default Ballerina dashboard that's there uh, in grafana.com. So it's already published. So we just have to load it. Oops. Select the Prometheus data source we created earlier, and that's it. So we can see here the earlier request that was sent. It's already there. And in this dashboard, all the default uh, information is there. So like HTTP service metrics, client information, failure rates, and all this information are there. And also some database access metrics are available here as well. You can see the sets are updating when the requests are sent. So this is basically by tracking all the service interactions, and it's visualized here. This is for the metrics part. Now let's check the tracing aspects as well. So for this, we'll go to Jaeger. In Jaeger, so we can basically select the service. So the name is our base context here. And if you find, you can see here, we have a single span, which has the information about our request on the greeting request, and the information on that is there, the durations and all that information. So you can also add your custom tags and so on if you want to enrich these messages in the code. Um, uh, Let me quickly show how that is done as well. So these are all done by default. So let's say you want to additionally observe an like a function you have. So let's say we write a new function called just say add. So call is, so here I'm going to add some path parameters. And I'm going to return an int directly. So I can say observe observable, then this function invocation will also be observed. And also I can do some further enrichment to the information as I mentioned earlier, um, like add tags to the spans. So I can say a value is so on, add to the current span itself. So there's a possibility that it can return an error. Let's do some error handling as well. So let's get the result also. Okay, now let's run this one and see. Okay, that's fine. Now we change our context to proc. Say, you can see we got the response. Now let's go and check our tracing information. So same service, let's do some tracing. Now we can see we have two spans, and because from our proc resource function, we also have the add function. And here we have the tags, AB, and the result as well. So likewise, we can easily enrich those information as well, but these other information we get automatically. And yeah, let's go to our uh, main scenario now, our main use case. So it's an integration scenario which integrates with multiple remote services in the internet, and it's basically a geolocation plus a geocoding scenario where a request is sent by a user, and it accesses a geolocation API to figure out the coordinates, latitude, longitude of the user by looking at the request IP. And after it returns the coordinates, the service does again another request to the geocoding service to get an address at the service. So it's an approximate address, of course, and returns that to the user. So we'll see how this interaction is tracked, how the default, like the automatic observer tracks this, and what kind of information we get out of it. And we'll actually be doing this in multiple approaches. So first we'll be doing a direct invocations of these services. Then we'll add another intermediate service to do request caching, sorry, response caching from the first service, uh, actually from the geocoding service. Um, and we'll again also see some database operations as well by caching these in a database. So we'll see how the database observability features are also working. And also we'll be using like HTTP, and also we'll end up with showing other protocols as well, like WebSockets usage. Uh, so let's start with the scenario. So the first Service is the location service HTTP one. So here I'll go through the code. The code is already available. So here, so I'll just explain what's done by that. So again, this just uses two services from Google. Uh, First is a geolocation one, as shown here in the link. And what we do is we basically, first of all, read in a API key as an environment variable and populate that and create a JSON payload saying consider the IP and do a post request to this URL. And we get from that we get the coordinates, latitude, longitude, and we do another call to the geocode API to get the address. So the address information is encoded in a rather sizable JSON message. So we had to process that message to get the actual address information we need. So I'll quickly show an example of that content. So this is a sample response like that. So here there are multiple address components and multiple entries. We want to actually look for the information that's there in this location type geometric center. That's the ideal one we want to get. So we have to look through all these entries here and get the address that's in the geometric center. So if you want to do this in code only, it's a bit of a tedious task. So here in Ballerina, we are using language level query feature, which is like an SQL-like dialect that is used to query the data that we get, basically the JSON message. This is similar to basically like link that you would find in C# and so on. So likewise, we have some features based on that in order to like do similar kind of processing in an efficient and intuitive way. So we do that processing and we get the addresses and we basically return that address with the earlier location information. So let's do a run of this and see. So again, we just do a better run. Okay, and let's send a request here. It's location service location. You can see here I actually got a address near to my place actually. So it did the whole round trip and got the response. Um, so here also I have the observability enabled. So likewise, in similar to the earlier scenario. So this should have ideally uh, publish those data to our service. So let's go and quickly check. So here, it is in the last minute, we can see. So we got the information and also for the tracing. You can see we have the location service. We do the traces. We get these spans by showing the starting from our resource invocation and which has this information and also the remote call. This information that goes to the geolocation API. So all this you can get the details on the on the request latencies, the request durations, and all that information. Now, as a next step, let's extend this a bit. So as I mentioned, I'm going to add another service in the middle to cache this data. And that is done in this other implementation I have, saying location service should be cached. So here, I'm basically talking to another internal service. So here saying check my local data first at this service for the geo service. If it's not there, if it's not available, we do the earlier same request and get the data, and also update our local data as well. So it's used as a cache. So the first implementation we have is like an in-memory one. So here, let's run that. So all these different services are again configured with the observability configurations. So if you go to config toml, I have said I have given it a unique Prometheus port. So Prometheus will be polling all these different service ports to get the data. So my in-memory, the local service is running. And so let's run this service as well. What happens? So the same request. You can see here it said the local service miss because in the first one, in the local cache, there's nothing there, and it stored the request. So the subsequent one should be quick. So it's hitting the local in-memory cache and it's getting the result. So it should be reflected here as well. And if we go to the tracing information, we can see now we have more traces, which this geo service look up as well. So the first one, actually, there are more holes with the due to the caching, and the caching, and because the first one you check if the request is not there, there's another store request as well, where you do a post request to store the requested information locally. So that's why you have extra steps here, which you can see here in the tracing information. So likewise, there's the next step would be the database one. I'll quickly show that as well. So, so here, rather than storing the details in memory, we store it in a database. So here, my database is already populated. Okay. Is there. Okay, now, okay, same thing happened. The first one it missed, then it's stored. So I have the request. the subsequent ones are quick. So here also, if these are updated now, also we have the SQL related stats as well, the most used operations and so on. And also in the tracing, we have the database based operations shown here as well. You can see the MySQL clients, query, and so on. So all this information is captured automatically, as you can see. So you don't have to write any extra code, but most of the useful information is already there. So in the final demo here, I'll also quickly show the WebSocket information as well. So here, the WebSocket implementation will simply use the existing HTTP service to route the request. So the WebSocket service will contact the HTTP endpoint that we already have here. So in that service, so you can see here, it's a WebSocket service that's started up here, which contacts our earlier service. So we start that, and let's just get some JavaScript. So then we just send a message, and we should get back the location. So as you can see here, likewise. So, and again, all these operations starting from the WebSocket service, everything is tracked here as well. So that's how you mix and match these different protocols, and how the service, the tracing information, the context propagation, and everything happens. So that's all done automatically, and so those information is provided to you by the platform itself. And now let's quickly move on to one of the cloud solutions we have that complements the Ballerina's features. So now we saw like how like the observability provider, the default observability provider is used, where we use Prometheus and OpenTelemetry based providers to do the metrics and the distributed tracing. Also, we can plug in other observability providers as well. And W0 has a cloud solution, which is basically an enterprise iPaaS, which is for developing low code and pro code based integrations, cloud native integrations. So as you can see here, there's the main highlights are mentioned here, and one of the main things are its deep observability features, where you can observe different aspects of your program itself, how each aspect is working automatically. So there's some cool features available there. So I recommend you to go and check it out. It's available as a beta release now. So here I'll quickly show how we can integrate the local running applications to use the observability features in W0 Choreo. So first, let's maybe go to the Choreo portal, and there we have something called a remote app. A remote app, we can give a remote name here. Let's say location service, and it gives a configuration that you can copy to your config toml. So here we'll use it to in our HTTP the endpoint service. Okay. And also we have to, okay, so the Korea package should be imported as well. So actually here now we don't need these ports. So now it's just a matter of running this service. So in Ballerina, we can also, we saw the Ballerina run command. We can also build and run the binary separately as well, which is actually the preferred way, because or else it gets compiled again and again every time we use this. So we do the Ballerina build, it'll compile and generate the executable. Okay, now we just run this. You can see here, you get some logs saying it's connecting to the cloud in so the Korea service to communicate with it for sending the observability data. So now let's do some sample requests. Actually, let's clear this and send some requests as well. Send some two requests. Okay. Okay, we see that our code is visualized here. So in Ballerina, so the code can be visualized as a sequence diagram as well. So it's built from bottom up to be able to do this. So the code can be converted to a sequence diagram, and the sequence diagram can be directly transformed to the code as well. So it goes both ways. And so without any additional mapping or anything like that, the syntax is created to be to able to support this. So here we can see we get this information like all the calls, network calls that are done here. We clearly visualize these here and say give the latency information, the success rates, and everything is shown in this sequence diagram itself. So it's very easy to visualize compared to just the spans view that we have in the in Jaeger that as we saw earlier. But this view give a, I would say, a more natural view on how on looking at the observability data. And also we can drill down to our other functions as well, like our lookup function, and you can see the success rates and other information as well, the latest information. And you can see here it says 67%. The reason for that is actually I made the request and actually one is considered as failed because of the cache miss. It returns 404, and due to that it records it as failure. So I sent say three requests, one failed. That's why it says 67%. So I just sent now. It hit the cache, so I really should update eventually with probably 75% success rate. So it'll process and update the UI. Yeah, you can see here it became 75%. So likewise, so it updates in real time. You can see here all the interactions here, the latency information, and all the constructs that are used to execute this flow. Same here with the other function as well. So yeah, so Choreo is in beta now, so public beta. So you can come and try this out as well, and give feedback, and hopefully it will be a useful tool for your microservice development as well. Um, so that's basically it for my presentation. And for additional resources, you can check these links. So the demo scenario, you can find it in my GitHub repo. So all the source code and the resources are there with the instructions. And also the Ballerina guides, they are in the ballerina.io website. So there are like a comprehensive list of examples and in detailed user guide as well. This is the link to W Choreo. So you can check it out and play around a bit yourself. And for other community channels, so we have a Slack channel where most of our Banner developers hang out. So you can come and join, talk with the people, give feedback, and ask questions if you have any, get some help. So we encourage you to join there. And also Stack Overflow, you can use the Ballerina or Ballerina Lang tag to ask questions as well. So I hope you found this session useful. Thank you for joining.